everyone. So today's lesson is section 1.2, points, lines, and planes. And it's really like my favorite day because it's our first day of geometry. Okay, so in geometry, we're going to be learning lots of definitions, lots of things called theorems and postulates, which we'll get to later. But a definition uses known words to describe a new word. Well, in geometry, some words, such as point, line, and plane, are undefined terms, meaning I have to tell you, we have to come up with an agreed upon name or definition for them so that we can define other things using them. Okay, so what we have to do is we have to actually agree on their definitions or their undefined definitions. But a point, a line, and a plane. So a point is something that has no size. We tend to always put a little dot to indicate a point. But remember, it's just a representation. A point really has no size. We indicate it with a capital letter. With a capital letter. So like I could call this point A. All figures consist of points. So you can see the figure to the right consists of a lot of points. They consist of points. And actually, you've learned about points specifically in algebra on the coordinate plane, okay? On the coordinate plane, a point actually is an ordered pair. And we are going to be talking about ordered pairs this year. And remember, an ordered pair has an x coordinate and a y coordinate on that plane. Okay, so I'm going to go back to that picture of, this is actually, where planes take off. If you can imagine, my plane is right here and I'm getting ready to take off. That's a point, okay? All right, a line. A line is something that extends in two directions infinitely. And actually, I should say it extends in opposite directions infinitely. You need to have at least 2 points to create a line. But if I have 2 points, then a line can be created. We usually use 2 capital letters and we put a line symbol above it. So that symbol is actually important. Symbols take on a lot of meanings in geometry, so we're really going to have to be comfortable with these symbols. Okay. I also could write like this, line A, and usually I'll do that. It will be a lowercase letter that I'll use for that point, but you'll see it in the book, okay? All right, and so if I think back to this picture of this runway, and I think about the sides of the runway extending on infinitely, those are lines, okay? All right, a plane. A plane is a flat surface that extends infinitely in all directions. So it extends infinitely in all directions. Usually when we are drawing planes, we usually draw like a triangular shape or a rectangle or a parallelogram to represent a plane. Planes, you need at least 3 points to make a plane. Okay. In the diagram below, a plane could be A, B, C, D. Okay. Since it's a rectangle, I'm going to use 4 points. If it was a triangular figure, I could use 3 points. But again, they're all going to be capital letters. Okay. All right. So these 3 points are going to lead us into some defined terms. And these defined terms, we really have to have a good understanding with to get started into the real fun of geometry. Okay, so the first one is collinear points. These are defined terms that we talked about in class today. But collinear points are points all in one line. So if I have a line with the points A, B, and C, A, B, and C are collinear points. They're on the same line. All right, whereas coplanar points are points all on the same plane. So if I give you this, A, B, C, and I tell you that this is plane G, then A, B, C are coplanar points. Okay. A line segment. A line segment is a piece of a line with two endpoints. Now, it consists of the endpoints and every point in between the two endpoints. So if I would call this line segment AB. The symbol I would use would be just a straight line above it with no arrows, so no arrowheads like that line symbol we used. And it includes any other point that's in between A and B. Okay, ray is another piece of a line. It's a piece of a line, but it starts at one endpoint and it goes infinitely in one direction. Okay, so I could give you A, B, C, D. Okay, A, B, C, D, and I can connect them with a line. Well, I could say that ray BA would be this ray. So starting at B, going towards A forever, we would write that BA, and the symbol we would use would be, it would have one arrowhead on the right side. The end point always comes first. So if I was talking about ray BC, BC would mean starting at B, going towards C forever. Now the same ray actually could be named BD. The endpoint, again, is the first letter that goes in it. Now opposite rays, that's important. Opposite rays actually start at the same endpoint and go in opposite directions. So BA and BC are opposite rays. And what I hope you notice is that if I have opposite rays, one going this way, one going this way, they actually create a line. They create a line, okay? All right, so let's look at an example of all these definitions. Now again, we talked about these in class. This is more formalizing of them for you. We want to name 3 collinear points. Okay, so there's lots of ways I could do that. I could say LMN. Those are on the same line. I also could say KMP. Now, you may notice that the line is actually dotted going through it. That means that it's actually going through that plane. Think of a piece of paper, if I stuck a pencil in it and was holding the piece of paper and the pencil was going through it, K, M, and P would be on that pencil. So K, M, and P. So those are collinear points. 4 points that are not coplanar. That means they are not on the same plane. All right, so how about R, N, M, and P? Okay, those points are not on the same plane. R, M, and N are on the same plane. M, N, and P can be on the same plane because remember 3 points make a plane. But that 4th point, different place. All right, let's name some points that are not collinear. Okay, not collinear. So there's lots of options here for you. I could say K, M, and L. Those are not collinear points. They are not on the same line. All right, now I'm going to ask you to pause and and I want you to draw all of the different options I gave you. Now you may need to go back and look at the definitions, draw them, and then come on back to the video. Okay, so you're back. Now hopefully when you drew them, this is what you have. Now points A, B, and C, you could have drawn them vertically. I drew the line horizontally. D, not on A, B, C. Line A, B, I knew that was a line because it had the arrowheads, so I drew a line A, B. Ray B, D, I knew the endpoint was B, so I drew a ray with an endpoint B going towards D. Segment CD, there's that segment symbol. I knew that those were the endpoints, and it was talking about every point in between. And then opposite rays, both with the point C as its starting point or end point, going in opposite directions. All right, a couple more things. Intersection. So this is a term that we're going to be using a lot this year and in algebra. The intersection of two figures is the set of points that are in both figures. Okay, they are in both figures. Intersect really means to meet or to cut through. Now, I gave you a kind of funny little picture here of some streets intersecting. The streets could be intersecting this way. It looks like the people can walk this way, and those would intersect. I could intersect this way and this way, going, like I could be crossing here and then crossing here. It's going to meet it at some point. But how many places can two lines actually intersect? Well, if I draw two lines and I put my arrows at the end, I hope that you had said to yourself that two lines can only intersect in one place. All right, so now we're going to practice sketching, okay? Sketching, well, I just drew two intersecting lines, so we should be able to draw two intersecting lines. Remember, if we draw a line, we want arrows at the end of them, and they intersect in a point. All right, sketching a line that intersects a plane. So this is going to be tricky for you. So typically what I like to do is draw a parallelogram. A parallelogram, we normally draw kind of as a slanted rectangle. Now, a line that intersects the plane, I'm going to go right to the center of the plane. I'm going to go straight up and draw a ray. Now, going the opposite direction, I'm going to put a dotted line. When it's dotted, that means that it's hidden from view. So that means it's coming out the other side of it. Okay. All right. Now we've got to sketch two planes that intersect. One of the ways, this isn't the only way, but one of the ways I like to draw planes that intersect is to draw a cube. So let me show you how I draw a cube. I first draw a square. A square has 4 equal sides and 4 right angles. Then I go to the middle of the square and I go up, over, and down to the middle of the side, and I connect them like that. All right, then I connect the vertex or the corners like that. So I have a cube, but now I've got to talk about the parts that I can't see, like the back of the cube. So I put in my little dots. And there I have a nice little cube, okay? All right, so two planes that intersect. I'm just going to label A, B, C, D, and E, and F. So I'm hoping that you can kind of see that if this is a plane here, the front of the box, and this is a plane here, the side of the box, then they intersect right here, and that was point B and point C. But since this is a representation of a plane, and planes actually go on forever, their intersection is actually a line, and it would be they intersect in line CB, okay? All right, so that's what I was looking for. That actually belongs over here. It should be right there. Describe their intersection. So the intersection of two planes is a line. Two lines intersect in a point. Two planes intersect in a line. Okay. Sketching two planes that don't intersect, we can go back to that parallelogram if we want. I draw something like that, and then I do like the back of the box like that. And so that's kind of showing that they don't intersect. Okay, a couple more things. I just want to recap, where do two planes intersect? In a line. We must use the symbol, okay? All right, so let's do some true-false here. I want you to think about A through F and try it and then come back and check. Okay, so hopefully you got that A was false, B was true, C was false, D was true, E was true, and F was false. If you got any of those wrong, I want you to ask in class tomorrow. Ask me, okay? and we will make you an expert on the topic. Okay, last thing, finding the intersection of two planes. Okay, so here I drew a cube for you. I have a nice cube. It wants us to find the intersection of plane HGFE and plane BCGF. Okay, so HGFE is this top plane, top of the box, and plane BCGF is this side of the plane. Now, what you might notice is that the letters have some in common. The common letters are G and F, and hopefully you see that these meet right here in G and F. So the intersection of those planes would be line GF. All right, now I want to name two planes that intersect in BF. Okay, so I'm going to switch colors. So here's BF. So the planes have to have that as a side to them. So I'm looking, and that is a plane. So BCGF. Don't skip points. Go either clockwise or counterclockwise. Don't say BGCF. You have to say BCGF. And then the other plane that I see that has BF in it would be the front of this box. So BFEA. Okay? All right. So hopefully you're feeling pretty good about points, lines, and planes. So I'm going to ask you to look at this diagram and name 3 segments and 3 rays in the picture. Take a second, do it, and come back and I will tell you the answers. Okay, you're back. So our segments I hope you got were LP using the segment symbol PQ using the segment symbol, or LQ. Those are all segments. The rays that I saw, I saw LP with the ray symbol. I saw PQ with the ray symbol. I saw LQ with the ray symbol. You could have said QP with the ray symbol. You could have said QL. So any of those would work. All right, guys, sorry that this first video was a little bit on the long side, but I promise they won't all be this long. Have a great night. See you tomorrow.